Welcome to the Computer World Terminology series. In this lesson, we'll explore two fundamental concepts in object-oriented programming: inheritance and polymorphism. These concepts are the backbone of modern software development and will help you write cleaner, more reusable code. Inheritance allows you to create new classes based on existing ones, while polymorphism enables objects to behave differently based on their context. By understanding these principles, you'll be able to design flexible and maintainable applications that can grow and adapt to new requirements. Inheritance is a mechanism where a new class, called a derived class or child class, inherits properties and methods from an existing class, called a base class or parent class. Think of it like real-world inheritance. Just as children inherit traits from their parents, classes inherit behaviors and attributes from their parent classes. This creates an ISA relationship, meaning a derived class is a type of its parent class. The main advantage of inheritance is code reuse. Instead of writing the same code repeatedly, you can define common functionality in a parent class and have multiple child classes share it. This reduces redundancy and makes your code easier to maintain and update. There are 5 fundamental types of inheritance patterns. Single inheritance is the most common, where one child class inherits from one parent class. Multiple inheritance allows one child class to inherit from multiple parent classes, though this can become complex. Multi-level inheritance creates a chain of inheritance, like a grandparent class, parent class, and then child class. Hierarchical inheritance is when multiple child classes inherit from a single parent class, all sharing the same base functionality. Finally, hybrid inheritance combines different inheritance patterns together. Each type serves different purposes depending on your application's design needs. Most programming languages support at least single and multi-level inheritance, while some also support multiple inheritance. Polymorphism means many forms. It's the ability of objects to take on multiple forms or for the same method to behave differently depending on which object calls it. Polymorphism works hand in hand with inheritance to provide runtime flexibility. When you call a method on an object, the correct version of that method executes based on the object's actual type, not just its declared type. This allows you to write code that can work with objects of different types through a common interface. Polymorphism enables flexible and extensible code design. You can add new types and behaviors without modifying existing code, making your applications easier to extend and maintain. It's one of the most powerful features of object-oriented programming. Polymorphism comes in 2 main varieties: compile-time polymorphism, also called static polymorphism, and runtime polymorphism, also called dynamic polymorphism. Compile-time polymorphism is resolved during the compilation phase. The most common example is method overloading, where you have multiple methods with the same name but different parameters, such as different data types or different numbers of parameters. The compiler determines which method to call based on the arguments provided. Runtime polymorphism is resolved during program execution based on the actual object type. The most common example is method overriding, where a child class redefines a method from its parent class with the same signature. At runtime, the correct method version is called based on what type of object is actually being used. Access modifiers control the visibility and accessibility of class members. Public members are accessible from any class, anywhere in your program. Private members are accessible only within the same class and are hidden from the outside world. Protected members are accessible within the same package and from derived classes. Default access, which uses no keyword, is accessible only within the same package. These modifiers work together with a principle called encapsulation, which means hiding internal implementation details and exposing only what's necessary through a controlled interface. Getters and setters are public methods that safely access and modify private data while performing validation. Data hiding, the core principle of encapsulation, protects your object's internal state and ensures data integrity. This creates a protective boundary around your class, preventing unintended modifications to critical data. Let's examine a practical inheritance example. Here we have an animal class with a public method called eat. When dog class extends animal using the extends keyword, it automatically inherits the eat method. Dog doesn't need to rewrite this method. It simply gets it from its parent class. Dog can then add its own unique methods, like bark. When you create a dog object, it has access to both the inherited eat method from animal and its own bark method. This demonstrates how inheritance allows dog to reuse functionality from animal while adding its own specialized behavior. The key here is that we avoided duplicating code. If we had many other animal classes like cat or bird, they could all inherit from animal without repeating the eat method. Now let's see polymorphism in action through method overriding. The animal class defines a base method called sound that prints a generic message. The dog class extends animal and overrides this method to print woof. Similarly, cat class extends animal and overrides the same sound method to print meow. Notice that both dog and cat have the exact same method signature as their parent class, but with different implementations. When the program runs, if you call sound on a dog object, it prints woof. If you call sound on a cat object, it prints meow. The same method name produces different outputs based on the actual object type. This is the power of polymorphism. You can treat different objects through the same interface, and each responds according to its type. This flexibility allows you to write generic code that works with multiple object types. Inheritance and polymorphism provide several significant benefits for software development. Code reusability is perhaps the most obvious advantage. When you inherit from a parent class, you reuse all its functionality without writing it again. This saves time and reduces errors. Maintainability improves because when you need to update shared functionality, you only modify the parent class once, and all child classes automatically benefit from the changes. Extensibility means you can add new functionality by creating new derived classes without modifying existing, stable code. This is especially important in large projects where changes to existing code can introduce bugs. Flexibility and scalability allow you to handle different object types through the same interface, making it easy to add new types and build robust systems that can grow over time. These principles work together to create code that is easier to understand, modify, maintain, and scale as your application evolves. Let's recap the key points from this lesson. Inheritance enables code reuse through class hierarchies, allowing derived classes to inherit and extend functionality from parent classes. Polymorphism provides runtime flexibility by allowing the same method name to behave differently based on the object type. Encapsulation protects data through access modifiers: private, public, protected, and default, controlling what's visible to the outside world. The solid principles represent best practices in object-oriented design, including single responsibility, open-closed, Liskov substitution, interface segregation, and dependency inversion. When designing your classes, avoid creating deep and complex inheritance chains. Use meaningful names for your classes and methods to make your code self-documenting. Consider composition over inheritance in appropriate situations, and always test polymorphic behavior thoroughly to ensure correctness. By mastering these concepts and following these practices, you'll write cleaner, more maintainable code that's easier to extend and scale.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.